Another thing I'd like to point out is this idea that if you have many, excuse me, if you have many objects, entities, then and you want to show all of their relationships, it's usually nicer if you can include them in one diagram so that they only appear once. You could say the relationship between course and class is this. The relationship between class and enroll is this, but now you've listed class twice. So if you can make it happen in some, in some diagrammatic way, this is the way to go. A course such as cartography could have two classes, and if you think about it as maybe a section, right? Section 1, Section 2, English 101, right? We've got 5 sections of that going on because everybody's taking it. Okay. One more thing I'd like to bring up is this idea of indexes. Indexes allow you to access data quicker, and they do create additional overhead in that anytime you insert something, you have to update the index. But that makes the access speed go much faster. It prevents you from spending any time looking in places where where it's known that there are absolutely no values that meet your criteria. Indexes usually are done on unique values and or unique combinations of values, and each index is associated with only one table. I bring this up because in the GIS world, there's such a thing as a spatial index, and whoops, I guess I can't zoom in here. Basically, this allows you to, when you're doing a search, only search certain geographic areas. So, for example, I have this polygon. I know that there's no part of the polygon in here, so I don't have to search in area 4. And of course, the finer the index, the more accurate it is. If I was going to search on just this polygon, I could completely ignore all of these other 7 areas because I know that its index shows that it's only in here. And basically it draws an envelope around the feature, and any index grid that it intersects it knows about. So allows you to retrieve data faster, and makes it a little unnoticeably longer to insert data. Whoops, and why is this? So in summary, tables, basic building blocks of relational database, and we use them to connect things together so that we can connect things in infinite amount of variety. And the way we know how to connect one table to another is by use of keys. It helps you determine which record goes with which record. The ones that you only have to worry about: primary keys, uniquely identify a record in a table, and a foreign key, which allows you to go from one table to another, connects to the foreign key in another table, so that you can determine which ones are related. Okay, and each table must have a primary key to uniquely identify all attributes. It's possible to create a table without one, but it doesn't really fit the relational database model, so you should always do one. And then when we're doing joins, you want to, the join type itself affects the result set of any particular query. So just be aware that it doesn't change the original tables. It only affects the join set, a result set. And they're based on relationships. So make sure you know what the relationship is between one table and another, so that when you do the join, you'll have an expectation, a realistic expectation of what's happening.